Right, question 7. This is the final question, okay? And this is the critical path question. So we've got a network with some missing boxes, and these are just activities. Doesn't really say what they're going to do. Right. So given that critical P is a critical activity and the total float on G is 2, write down the value of X and the value of Y. So if we go to my lovely, where is X and Y? Oh, F is X is on the length of F. And so F is a critical activity, so that means if it's a critical activity, then those boxes must match. So I've got the 9 and 9 and the 21 and the 21. What that then means as well is the X that's in between, the length in between them, has to be the same as the gap. So 21 take away 9 gives me 12, so I know that X is equal to 12. Don't need to put any working out because it just says just write down your answer. The second bit of information it gives me is that the total float on G is 2. So that means if we go on to this bit here, it's got a float of 2, so it could start at 21, finish at 26, which is a gap of 5. It's got a float of 2, so that means the length of it must be 3, otherwise that wouldn't work. So then y is equal to 3 there. Okay, part A done. Tick. Part B, calculate the missing early event times and late event times and hence complete diagram 1 in your answer booklet. Okay, so to get the early times, remember you're going forwards and you want to choose the biggest number every time, even though it says earliest, you still need the biggest one, okay? So, looking at this box, the one that's beside the A and the dummy, we've got a choice of 0 plus 8, or we've got a choice of 9 plus 0. We want the biggest one, so I'm going to pick 9 to go in there. If I look at this one here, I've got a choice of 9 plus, what did I say X was? 12. Which is 21. I'd already sussed that out before from knowing that F was the critical activity. Right, so moving up here now, I've got 9 plus 7, which is 16. I've got 21 plus, that was 3, so which is 24, and that is it. So choose the biggest one, which is 24. Down here, I've got 28 plus 0, which is 28. 21 plus 9, which is 30. 21 plus 11, which is 32. That's going to be the biggest one that I'm going to get, so that must be a 32 into there. Right, okay, so now looking at the other ones, the late times, and remember we want to choose the smallest number when we're working backwards, and you need to check all the ones that go in. So this box here, there, I've got 26 take away 3, which is 23. I've got 32 take away 11, which is 21, and that's the smallest one, so I've got 21 there. Looking at the one up here, I've got 26 take away 7, which is 19. I've got 21 take away 4, which is 17. And that's it going backwards into it. So, smallest one is the 17. And lastly, the one at the bottom, I've got 17 take away nothing, which is 17. I've got 21 take away 8, which is 13, struggling with numbers today, and 21 take away 12, which is 9, so it's the 9 that I want, so that must be a 9 into there. Right, so we've done that. Right, each activity requires one worker and the project must be completed in the shortest possible time. Calculate a lower bound for the number of workers needed to complete the project in the shortest possible time. Now it tells us that the total activity duration is 99, so the length of all the activity is 99. The critical path time is 37, so we can just divide them to get our answer of that. So I got this on the next one. So this is part C, this is. So I want 99, the total activity length, divided by the critical path. That's going to give me 2 point something. I will get the exact number by using a calculator. So 99 divided by 37 equals 2.68. Now, obviously, we can't have 2.68 workers, so we'll have to round that up to 3 workers, and obviously that would always round up because you definitely need them. Right, part C is done. Okay, part D, draw a cascade diagram for the project in the answer grid. Alright, so I'm going to draw this activity network into this grid here. I am going to try, hopefully this will work, and do a bit of dual paging. Can I make this bigger? Oh, I should have made it bigger before I drew the numbers on. Let's see if we can make it all bigger together. If we group those. Sorry, this is tremendously exciting for you to watch, I'm sure. Oh, yeah, fantastic. Right, so we're going to make this a bit bigger as well because then it'll be easier to draw. Obviously you don't have this problem because you can just, like, you know, open the booklet and it's all there. Right, so we're drawing a cascade diagram. First job is to put the critical path along the top. So let's find the critical path. It's going to be from 0 to 9. From 9 plus 12 is 21. Then it's going to have to go 21 plus, it's going to be that dummy there. Then 21 plus the 11 for the 32. And then 32 plus the 5 there. So I need to get those activities on there first, the critical path. So I've got B going between 0 and 9. And the critical path just goes along the top. So I've got B, which is there. Obviously yours is going to be neater than mine. I've then got F, which goes between 9 and 21. I've then got a dummy, so I don't draw that on. I've then got H, which goes from 21 up to 32. And then lastly, I've got M, which lasts for 5 and goes up to the 37. So there's my M at the end there. Okay, after that, each activity just goes on its own line, and because it's cascade, remember you need to represent the float time on there as well. So, starting with A, I've got, they could start at 0 and it lasts for 9, so I draw a solid line from 0 to 9, but it doesn't have to be finished until this 17 at the bottom. So then I do sort of dotted lines, or sometimes it's shaded lines to do on the, in the answer book, sort of like that, just so you can see it a bit clearer. But as long as you've got some way of representing that, that was activity A. Okay, B I've already done because it was on the critical path. C could start as early as 9 and go last for 7, so 9 plus 7 takes me to 16. But it doesn't have to be finished until 26, is that? Hard to read on the board, yeah, 26. So I then need to show the float going up to 26. So 26 is there. And again, just kind of shade, dot, whatever you do on that one, just to kind of represent the float bit. Right, A, B, C, D is next. D could start at 9, and D lasts for 4. So that's D, and we could dot D all the way up to 21 because it doesn't need to be finished until then. So we'll go on that one. D, E could start at 9 and last for 8. So that takes it up to 17. So this is from 9 up to 17. This was E. E doesn't have to be finished until 21. So then I just do my dots again up to that 21. Okay. Obviously, like I said, make sure you're using a ruler and making this look neat. It's a lot more difficult on the board than it is for you guys. Alright, we've got F, it's on the critical path. F, G, G we need, G lasts for 3, starting at 21. So, 21, lasting for 3, that is G, but G doesn't need to be finished until 26, so I've got just a little bit of float on there. H is on the critical path, H, I could start at 21 and last for 9, so from 21, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is H. H doesn't need to be finished. No, it's not H. What was it? G, H, I. It was I. That's I. And that doesn't need to be finished until 32. So I just get a little bit of dotting up to that 32 there. J is at the bottom there. So 21 it needs to start and it lasts for 7. 1, 2, 3, 4, 5, 6, 7. That is J. Doesn't need to be finished until, I can't even read that on the board, 32. So again, it gets dots going up to 32. JK could start at 24, last for 10, and doesn't need to be finished until 37. And K and L is my last one because I've already got the M. So M could start at 24, last for where am I? Sorry, I'm doing L. Last for 6. So 1, 2, 3, 4, 5, 6. It doesn't need to be finished until 32. So we'll get some dots on the end of that one as well. Right, and that is my exceptionally neat, cascade diagram. Alright, going back to the questions now. So, there we go, that's it bigger. Obviously you can see that when you zoom in it's not very neat, which is why you're going to use a ruler on yours. Right, so we've drawn our cascade diagram on grid 1. Fantastic. Okay, part E. Use my cascade diagram to determine the minimum number of workers to complete the project in the shortest possible time. You must make specific reference to times and activities. We do not need to provide a schedule of the activities. Alright, so going back to looking at my diagram on this, okay. In fact, I'm going to make it smaller again. It was almost easier when it was smaller. Right, we need to find a time when the most activities have to be happening, okay? So, I'm going to hazard a guess that it's going to be somewhere around about this area, because you can see we've got the K, the L there, the G there. This one at the start, we can kind of shift the A, the B's, the C's around quite a bit so that we don't have to be doing them there. So I'm just going to try a few sort of different times. This one looks pretty busy, so I'm going to just sort of try going down there and see what has to be happening at this point. Obviously H has to be happening. I also has to be happening, because even if I shift that along to the floor, it still needs to be going on. Again, J needs to be happening. K has got, how much floor has it got at the end of K? It's, again, because of my diagram's not too neat, it's quite difficult to tell. So K has got 3 ones of there. So if we had it between the 27 and the 28, K would have to be happening as well. And L, again, we couldn't quite shift that along. So between between 27 and 28, and I'm going to just write this here, between 27 and 28, 5 activities must be happening. So that means that we are going to need 5 workers. So 5 workers needed for that. I don't know why I wrote that bit in red. There we go. So going back to the question, just checking that we've got everything. We made specific reference. We didn't do the schedule. Tick. And that is that question completed.